Hi folks, this is part 3 and this is AutoCAD again, and I've drawn these shapes here in 3 dimensions. So we've got a square, a sphere, a circular disc and an irregular shape. So if I just go to the 3D view of them, do a regen. So the sphere here is drawn to the exact size of the Earth. If I click it and click properties, it's telling me the radius is 3959 and the diameter is 7918. So that's in miles. This disc is drawn, the diameter is double the diameter of this sphere, so roughly the size of the commonly believed flat Earth. This square is drawn, the sides are the same as the diameter of the flat Earth, and this is just a sort of random irregular shape drawn to roughly the same size. In the centre of them all, I've drawn a vertical and a horizontal column. This horizontal column is exactly 6 miles from the surface here. So at that intersection there, it's 6 miles in altitude, and I've done that in each one of them, right from the surface, and the sphere from the sort of top polar surface. What I then did is exported these into a program called Autodesk Navisworks. So you can see them here, plan view. One thing to note that I saw straight away is that when I imported them, the program actually renders this sphere by putting a diminishing light around the edges. That sort of gives you a visual representation of a sphere. The disc look is the light is just uniform throughout the whole of the surface. So if I go to Google and just type in moon images, in every image of the moon that you can see, the full moon, the light goes all the way to the edge. There's no diminishing of light on any of these full moons. It's only when it's sort of a half moon or a crescent moon that you can see the actual line of the shadow, and it's a definite line. But all the full moons, they're all uniformly lit all the way around. You can see the crescent on that one. It doesn't sort of show that diminishing light as it goes around the surface, around the sides. This program here, if you go to lighting, we've actually got set to headlights, so it's as if we are shining headlights directly on these objects. I can also select scene lights, which puts the light from a sort of different direction. You can see here the light's coming sort of from our top right. Just thought I'd point that out. That's an aside to this video really. So I can navigate my way very slowly to the centre point where I put them columns, and this is quite laborious, trying to find these columns and align myself with them. So I'll do the first one here, and then for the rest of them I've saved the views so that we can just flick between them easily. Where is it? There it is. You can see the column just appearing there. Like I said, it's very tricky to get myself aligned with it. I'm inside the square at the minute. Anyway, I have to spend a lot of time aligning myself with the horizon there. So I've saved the views, so I've got square over here. So what we're looking at is if we've dug a hole in the surface of the square, we've climbed down into the hole, and we're looking out at the horizon, sort of dead on our eye level, at ground level if you like. And you can see, because we are inside it and we're at ground level, we can see the sort of underside of the square here and the walls. You see this underside coming away from you. So what I'm going to do is simulate ascending vertically in a helicopter. I'm going to go to 6 miles again. I know helicopters don't go to 6 miles, but just for viewing purposes, I'm going to assume it can. So let's ascend. There we go. So our eye level now is dead on the horizon. And even though it's a square, it's still very, very flat at this altitude. So let's continue higher, a lot higher. We've gone way, way above the 6 miles now. And as you can see, as we get higher and higher, you can see the square start to appear. And just keep looking down on it, looking down there, and ascend higher. Let's go back a bit, so you can see the square. Let's go to the circle. So this is the disc. And again, we're at eye level. One thing I forgot to mention is that the horizon line, the only way to depict where eye level is really, from our perspective as we're looking at this, is this arrow here, which is a tool in this program. You can see the horizon sort of crosses the center point of that arrow there. So that is how we know we're at eye level. When the horizon is, when the horizontal bar, the red horizontal bar is in line with this arrow, we know that we're at eye level. So let's ascend on the circle, on the disc. So we're up to 6 miles. I've got to do this slowly, otherwise it goes zooming past. There. So again, the red line there crosses this arrow about halfway down. And already, I don't know if you can see that, you probably can't very well, it's already started to form a curve. And that's right, a curve on the flat Earth. Who'd have thought it? Let's keep ascending, and as we ascend further, the curve, as you can see on the here, look, the curve is, the horizon is dropping at the edges. Keep moving up and up and up, and eventually, if we go high enough and far enough back again, obviously we see a curve. The point I'm trying to make here is that even on a flat Earth, the horizon will appear to be curved. It has to. At some point it has to, if you get high enough, because it is actually a curve. So if you're looking down on it, logically, you will see a curve sooner or later. Quickly go to the irregular. Again, the horizon is crossing this arrow, or our eye level, sorry, is crossing this arrow. Let's ascend. We just might as well go straight up now. Yeah. So even the irregular shape starts flattening out. We're not even down to the 6 miles yet. You'll see when we do, when the red line or when the horizon sort of crosses this and we're dead on eye level. There, oops, just too far there. Let's go to the sphere. Okay, I had to draw the column down into the sphere because to try and align myself with the horizon here was very difficult. It was different to all the other shapes. Just trust me, it was. So let's ascend. Before we do, the horizon's looking very flat. So let's ascend up to 6 miles, and we need to put the bar in the centre of this arrow. So now we're at eye level. This bar is at eye level at 6 miles. And you can see, as my previous videos show, the horizon is below eye level. So this, from here down to the horizon at this point, would be the 3.15 degrees from my previous videos. So let's keep ascending. Just to complete the video. Come back a bit. So the only other possibility that we've not looked at is the infinite plane, but unfortunately on this software I can't simulate the infinite plane. I have to give objects physical constraints or dimensions, and since infinity would be infinity, it won't let me do it. But suffice to say, in my opinion, what would happen on the infinite plane would be that no matter how high you ascended, the horizon would remain at eye level indefinitely. So I hope you've enjoyed this video. It's just to show perspective really, nothing groundbreaking. We obviously can't do these sorts of things in real life, so I guess we rely on computer programs like this to give us an idea of what things would look like. I know it may not be 100% accurate, but I don't know. Interesting nonetheless. More videos still to come. I'm going to dwell on the the light on the moon issue a bit more, amongst other things. So if you're interested, please subscribe.